Okay, in this example, we're trying to find a coefficient of friction. We have a child on a sled in snow being pulled at 120 Newton applied force. 45 kilograms is the total mass of the sled and the boy. It's our job to find the coefficient of friction. So what does the question need? It needs a condition. Let's say this sled is being pulled at constant velocity. Let's see what the forces are on this object then. Straight down, of course, force gravity. Upwards is the reaction force known as force normal, perpendicular to the incline. We'll show congruencies between the two forces. Our 120 Newton force is the applied force. And opposing this is going to be the friction force. A constant velocity means there is no acceleration. Thus, the friction force must also equal the force applied. Let's write the net force equation. Force net is equal to force applied minus force of friction. Reminder that we include the forces in the x direction mostly when dealing with net force, because we know normal force and force gravity balance each other out on horizontal inclines. We always put in mass times acceleration for force net. So we'll say 45 times 0 equals our force applied, 120, minus force of friction. We can see mathematically force of friction must equal 120, which is equal to the applied force. Our question is, how do we find the coefficient of friction? Well, the equation for force of friction is equal to force normal times mu. Force normal, again, equal to force gravity. Let's fill in for force gravity here. 45 times 9.8, because force gravity is mass times acceleration of gravity. That equals 441 newtons. Now we can put numbers into this equation and find mu. 120 is equal to 441 multiplied by mu. Mu is equal to 0.27. Now in a second question today, we can apply the concept of friction forces to a question. What if a skier came down from the hill and is going to simply coast until a complete stop? Our initial velocity is 23.5 meters per second and is a coefficient of friction of 0.12. Well, once again, we'll put the forces on the object. Force gravity straight down, balanced out by a force normal upwards. And we can show congruency between both of those forces. Going against the skier is force friction. In this case, there is no applied force because the person is simply coming to a complete stop. So force net is going to equal a minus force of friction. Again, being negative because it's pointing towards the left. Now we don't know the mass of this person, so we're going to leave some variables in there that may cross off for us today. Force net equals mass times acceleration is equal to minus force normal mu. Remember, normal and gravity equal each other. In this case, force gravity will equal m times 9.8. We leave a variable m in there because we do not know the mass. Substituting into the above equation, mass times acceleration is equal to minus m times 9.8 times our coefficient of friction of 0.12. In this case, masses will cross off because m is on both sides. Acceleration then is equal to minus 1.2 meters per second squared. We can then use a Fab5 equation in order to find the total distance the skier goes while coming to a complete stop. we'll choose the V2 squared equation. Subbing in 0 squared is equal to the velocity beginning 23.5 squared plus 2 times negative 1.2 times d. Solving for d, we get 230 meters for the stopping distance for the skier. Should say